In this series of videos, you're going to learn solutions to a lot of logarithms problems. Logarithms is not a difficult or complicated topic. If you want to understand this topic very well, you need to know the basic properties of exponents very well. So first, let's talk about why we need logarithms. Now, I'm going to ask you two questions. So the first question, if 3 to the power of x is equal to 9, then what is the value of x? This is the first question. And my second question is, if 3 to the power of a is equal to 11, then what is the value of a? Okay, so I know you found that x equals 2 in the first question because 3 to the power of 2 is equal to 9. 3 to the power of 2, we multiply 3 by itself twice. 3 times 3, which is 9. So x is equal to 2. But I don't think you can find a with the information that you learned so far. When you learn logarithms, you're going to be able to find a. So let's get started with the first and the most important property of logarithms. Alright, so if a to the power of x is equal to b, then x equals log base a of b. This is the first thing you have to know about logarithms. Okay? When you have a to the power of x equals b, then x, which is exponent, is going to be equal to the log base a of b. Okay? So it's so simple. As you can see, the exponent right over here is going to be equal to, or you're going to write the exponent, and then you're going to put the equal sign, then you're going to write a log. So whatever the base here, as you can see, base is a. So base is going to be a. Then you are going to write this number right over here. Okay? So let's say that we have x to the power of y is equal to z. Then our exponent is y, as you can see here. So y is going to be, let's write log. And then what is the base here? So the base is x. So we are going to write x here as a base. Okay? And z is going to be right over here. So y equals log base x of z. Alright, so now let's do a few examples about this. So for example, let's say that 3 to the power of x is equal to 7. Then, as you can see here, x is the exponent. So x is going to be, and then let's write log. So we are going to write 3 as our base, because base is 3 here. So log base 3 of 7. Whatever this number is, we're going to write that number right over here. Okay? So x is going to be log base 3 of 7. So let's say that we have 2 to the power of x plus 1 is equal to 5. Then the exponent is x plus 1. So the x plus 1 is going to be log, the base is 2 here, so log base 2 of 5. And let's do another one. Let's say that 10 to the power of x minus 3 is equal to 9. So the exponent, x minus 3, is going to be equal to log, our base is 10 here, so log base 10 of 9. Alright, so we learned that when a to the power of x is equal to b, then x equals log base a of b. So we can also say, if we know that x equals log base a of b, then we can also write a to the power of x is equal to b, or b is equal to, so this number right over here, or this expression right over here, b, is going to be equal to a to the power of x. A to the power of x. So let's do a few more examples. For example, if we have log base 5 of x is equal to 2, then x is going to be 5 to the power of 2. 5 to the power of 2. Okay? So that means 5 to the power of 2 is, we multiply 5 by itself 2 times. 5 times 5, which is 25. So x is going to be 25. Or let's say that log base 4 of x minus 2 is equal to 3. Then we can write this expression is going to be equal to x minus 2 is going to be equal to 4 to the power of 3. 4 to the power of 3. If x minus 2 is equal to 4 to the power of 3, so let's first find 4 to the power of 3. 4 to the power of 3 is going to be 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is going to be 64. So x minus 2 is going to be 64. So in order to find x, I can add 2 to both sides. So I'm adding 2 to both sides. So as you can see here, minus 2 plus 2 is going to be 0. So on the left side, I'm going to have only x. X is equal to 64 plus 2, which is 66. Now I'm going to solve more examples about logarithms that I can use this property of logarithms. Let's start with this example. You can pause the video and give it a try. So as you can see, 2 to the power of x is equal to 5. So what is the value of x? So let's remember, if a to the power of x is equal to b, then x is going to be log base a of b. So here the exponent is going to be equal to, x is going to be equal to, because x is the exponent, log base 2 of 5, because base is 2 right over here, so base is going to be 2 here. Log base 2 of 5. Actually, we can use our calculator to find the value of x, okay? Alright, so let's use our calculator to find the log base 2 of 5. So base is going to be 2, and log base 2 of 5, as you can see, and let's say calculate. So log base 2 of 5 is going to be, as you can see, 2.3219. It keeps going on forever, okay? And also you can see that 2 to the power of 2.321928, 0, whatever that number is, okay? 2 to the power of log base 2 of 5 is equal to 5. So let's write only 2 decimal places after the decimal point. Let's write only 2 decimal places. 2.32. 2.32. So x is approximately 2.32. That means 2 to the power of 2.32 is approximately 5. So another one. 3 to the power of x is equal to 20. So the exponent, which is x, is going to be equal to log base 3 of 20. And we can use our calculator to find the value of x. And 7 to the power of t is equal to 14. You can give it a go first. Please pause the video and give it a go. So the exponent is t. So that's going to be log. T is going to be equal to log base 7 of 14. Base 7 of 14. Our next example, as you can see, we have log base 2 of x is equal to 2. So let's remember, if we have log base a of b is equal to x, then a to the power of x is going to be equal to b, okay? A to the power of x is going to be equal to b. So here, x is going to be 2 to the power of 2. 2 to the power of 2 is 2 times 2, which is 4. So x is equal to 4 is the answer. And let's look at the next one. So in this case, y is going to be 3 to the power of 3. 3 to the power of 3. And 3 to the power of 3 is 3 times 3 times 3. We multiply 3 by itself 3 times. So that means y is equal to 27, because 3 times 3 is 9. And 9 times 3 is 27. And let's look at this example. Log by 7 of x is equal to 1. Then what is the value of x? So x is going to be 7 to the power of 1, okay? 7 to the power of 1 is going to be equal to x. So 7 to the power of 1. Any number to the power of 1 is the number itself. So that means x is equal to 7, the solution for this example.